Hi, welcome to this Open Security Summit session in one of my favorite topics in the world, which is graphs, which of course I then evolved graphs into a map, but it all starts with the graph. And I kind of wanted to do this because I have a number of ideas that I wanted to give to the Neo4j sort of community and team, and we're very lucky to have a good members of the Neo4j company who has had an amazing journey and is really evolving. So yeah, I'm Dennis. You probably know me by now. I've been doing the summit and all this stuff, and I'm all about graphs. So Irene, can I give a quick introduction?
Sure. My name is Irene Michlin. I've been with Neo4j for 6 months, and my role is to lead application security in our engineering organization. So at the moment, I'm less about security features, as in amazing usage of graphs for security. This is David and Dave will be talking about. I am more about secure features. So my role is to ensure every feature of Neo4j is secure. So we will touch about it a bit. And also, of course, threat modeling. So whoever happens to know me probably knows me in connection with threat modeling. And threat model is a property graph. That's what it is essentially. So this is my connection to today's event.
Exactly. Cool.
Yeah, good afternoon or good evening or whatever time zone we're in. This is Dave Fauth. I'm a sales engineer at Neo4j. I've been at Neo4j coming up on about 8 years now. So really client focused, client facing, and really work to help customers solve problems. And a lot of those really get into security, understanding security at the enterprise, understanding how their Active Directories work, and just trying to solve security problems with graph databases.
And good evening, I'm the other Dave. I've been with Neo for about 2.5 years now, one of the managers of some sales engineers here in our North American region. Before Neo, I was, I guess you could say, like a cloud architect at a startup, helping them pivot to Google Cloud and moving and shifting their infrastructure there. So I've been a little bit on both sides of the fence. Currently working on the vendor side, helping customers embrace graph for various use cases, including security related, but also been on the consuming side as well, where I've had to be the one coming up with our plans and risk mitigation approaches for our infrastructure.
Cool. Right. So I think so. The way we kind of going to try to run this is I dropped a number of topics, and I really would like to keep exploring this because I was trying to find a good source of places about the great amount of work that's already happening around the Neo4j world, and there's actually some pretty cool stuff. So this is sort of what I found, and if there's anything missing, please help. This is a GitHub page, submit a pull request, and I actually think it's worth doing a further presentation with where we actually go into more detail into some of these. And actually I had a great chat with the guy from GraphCare. If he's here, please drop a note, and we'll make you so you can co-host, you can speak. We had a great presentation from Starbase actually already during the summit, which is really cool. And I think there's some really good materials already out there, and I think it's worth to explore. But because we don't have that presentation, let's actually go into some more of these specific topics. So the idea is that we'll cover this, and I'll just do a quick introduction. I put some notes, and then we can talk about it. So I think the first one, I think, Irene, is very close to your heart, right? Which is using graphs in threat models. And cool, yeah, Ben, let's add that, control framing mapping. So one of the problems I have with threat models is that they are static, most of them, and they don't have movement, and they're not based on real world data because there's somebody's drawing. And more importantly, they don't allow us to apply basic graph-like logic and queries and filtering and visualizations. And basically, a threat model fundamentally, if you went done right, it's a gigantic graph. In fact, you can map a massive part of the organization, just starting with the thread model and then starting connecting all the dots, where every element in there is actually a node and then a relationship. So, Irene, what do you think? From your threat modeling sort of background, what's your views on this?
So to have the kind of dynamic threat model that updates when the underlying reality changes, you need to express your reality in a language that you can consume then into a graph and do visualization of a graph. And there are lots of good tools that try it in variety of ways. I used to have a presentation where I list the existing tools, and since I last gave it, I think 2 new tools dropped, and people try to to describe it directly as a code, as some kind of pseudocode. And yeah, I think that's the only way forward, right? If you have it described and you modify it together with your code, and then the model sort of auto updates. So that's a high-tech end of threat modeling. But also I think there is a massive value in a low-tech end of it, where we only have white paper and, whiteboard, and we draw on it without any technology. And this also, you have a graph. You start talking, 2 minutes later, you will have a graph on this whiteboard, and then you do threat model around this graph naturally. So I used to start with, let me teach you the theory of threat modeling, and then I stopped. We just do it naturally, and people pick up it's a property graph, and we can reason about property graph.
But if you don't capture it, we in a way, we lose a big opportunity, right? Because
Yes.
like you said, you create a graph, right? It's not that you go out of your way to create a graph. You literally end up with the graph. That's literally what you've got. So if we can capture it, you start the beginning even of documentation, the beginning of how something works.
I agree. There is a big value add in capturing it in a format that you can put in your version control.
Yes, absolutely.
And
Which
taking photographs of whiteboard isn't that format.
Well, and actually, that's actually one of the topics I want to talk about later is versioning control. And Chris, absolutely. Can you unmute yourself, or do I need to make you co-host? Sorry. Where's the participants? Because Christian has his hand up. There you go. You should be able to do it now.
Yes, I can now. Thank you. I got one question because we were just talking about having a whiteboard with a graph on it. Did anyone ever come across a technology like you take a picture of it and it converts it into a graph in Neo4j or something like that? So, I mean, we have technology that can classify pictures or, well, identify is this a cat or not. And so I think it might be quite useful, because I think if you do a session with multiple people, and a board is naturally something that a lot of people would use, but then, as you said, then it gets lost. So if there's, like, you take a picture and it gets converted into data, which we can store, then that would be awesome. So I don't know if there's anything like that at the moment. Maybe someone came across it.
I don't think I've seen anything quite like that, to be honest.
Yeah, I'm not either. So it's interesting.
I've seen smart whiteboards that, you could draw on them and then it sort of digitizes it, but I don't know if it would convert it into something more structured.
But you can see the value of that, right? Because that again, lowers the bar of entry to get into the the graph world, right? Because that's again one of the challenges. How do we start having a graph? How do we start having something that can be manipulated?
Exactly, because not everyone writes code or is familiar with UML or another language to describe stuff. So yeah, I just think it might be helpful, but I have not seen anything. So
There are some.
Yeah, go.
I was going to say there are some standards, at least from like a file-based representation of how to represent a graph, and there's some open source tooling around that. We even have our own kind of virtual whiteboarding application available for free called, I think it's at arrows.app, if I'm correct. That it's we consider it sort of like a whiteboard to draw out a graph, because it's focused on representing graph as the data model. And you're able to give it some instance data inside what you're drawing and immediately kind of turn it into input for Neo4j. It'll construct like Cypher statements and whatnot to generate the
That was pretty cool.
transaction to build
Can
it.
you just show a quickly demo of it?
Yeah, let me pull it up here.
Because I feel that the challenge in a way when you start to create graphs is that we already have lots of graphs around us. In fact, even a spreadsheet is a graph. The challenge is then how to actually make it work. Cool.
Yeah, so if you go to arrows.app, I believe the source code is available in the Neo4j Labs GitHub project. It allows you to create one or many graphs and either store them in something like Google Drive or in your local storage in your web browser. The idea is you quickly draw out representation of a graph. You can give some information to it, like maybe this is a person. Technically, if I open up this panel, you can set labels. So then you can actually use the formal label property graph approach with arrows. And then everything that this does, say Dave, for instance, we're going to keep it super simple here.
and those can be converted into Neo4j or?
Yep, I'll say this is me.
Okay, cool.
Maybe I'm creating a relationship type of nose, and then I'll just delete this guy for now. And then if you download or export it, so it can give you the visual form as either a PNG or SVG, depending on what you're trying to do. But it'll also generate the Cypher clauses to insert that, or allow you to store it as JSON. There are some other structured formats for graph. I know from like the semantic web world, the last couple of decades, there are a few different formats for representing kind of RDF-based information, which is technically a graph. But when it comes to something that's more label property based.
Can you bring it through here? Can you kind of bring, how do we import stuff into this?
Into this view?
Yeah.
That's where I don't think we have an actual import capability unless you're already creating it in arrows today. So if you already had
Yeah, I don't know.
an arrows drawing, I think you can import from the JSON structure, for instance.
So I guess if you had something like draw.io and you can export it as JSON, then you should be able to import this JSON into this tool.
Yeah. I mean, in theory, somebody could extend this to say, okay, run some Cypher against a target database and pull back the same information to structure the visual. It's just, I don't think anybody's done that yet, to be honest.
Yeah, because you see, like one of the things that I think is very powerful is to have a graphical representation as code, as readable code. And if you look at the YAML file, a YAML file is a really great representation of a graph, because you can version control it, you can maintain it. So you can see that even what you have here can be transformed into a couple of YAML files that you can then bring in. The advantage of that is then you can version control that situation. You can make changes, you can visualize it, and then you can bring it here into, for example, something like this to manipulate it, to do further changes. And then you kind of want to make sure you have a round trip from one to the other. Because the problem with this is that users create information, but where is it stored? And how is it maintained? And are you going to edit it? And how do you keep that consistency? And how do you have some schema, that you then start to apply and you basically evolve it as you find out things?
Yeah. And there is, this is the format I was talking about, I believe. I think I'm sharing my full window, GraphML.
Yeah, GraphML.
So there's some tools that natively import or export GraphML. And I know Neo4j has some additional tooling to ingest this type of structured data. I mean, from my experience, if we're talking about version control and we're talking about structured files, you sort of end up in that situation where it's almost not as easy to do as like regular text-based, if like it was source code, could just, because if you're changing something graphically in like a GUI, even just the position, for instance, might be structured in the output file. And next thing you know, maybe it's re-rendering that JSON and it looks like an entire file update. So it's more like file level versioning than like, source level change versioning type thing.
See, this is why one of the things sometimes I mention is that the fact that sometimes you don't control the design is actually a good thing, because you remove a level of complexity. You actually start to create graphical representations that are repeatable, that you can actually make small changes and they are much more sustainable. Where, I agree with you, like, some of these, you end up with a massive salad of stuff because you're actually capturing the pixel and the things. And that becomes almost a serialization of Visio, right? Or a serialization of Draw.io. And that's not what we want. What we want is to capture the data and the relationships, and then almost zoom in and zoom out and create the views based on what you want to know and the questions you want to be asking. Because if you go back to thread models, some of the best thread models I had was actually when we already had a lot of architecture, where we already had a representation of reality. And we almost start the session by asking the question, hey, this is what we know about your world. This is what we know about how the app works. Does this make sense to you? Is this something that it actually relates to you? And that works really, really well. And a variation of that is, I've also done others where I had things, I think it was dot at the time, but I had the dots, the text, and I had the window, and I maximized the window on a big screen, and I was literally typing the architecture as we were talking about. So it's not like, imagine somebody on a whiteboard, maybe, Christoph, this is kind of maybe the compromise. The compromise, if it's easy for you to keep typing as almost you're drawing, you almost get the same kind of situation, right? Okay, it's not machine learning, it's not automatic, but there's something to be said for starting to almost build the architecture in front of everybody, and everybody starts to see if that's what happens, that's not what happens, and how it flows.
Yeah, for me, it was more about the entry barrier. So,
yeah,
I mean, you might be able to do it. My Cypher is not that good, so for me it's very hard, and I would take a lot of time
Cypher, to be
or
honest,
whatever,
yeah,
or dots, or
yeah. I think Cypher can become very, very complicated very, very fast, right? So, cool. Let's actually, I want to skip this because there's actually a good. There's a couple of topics here, but they actually are covered in the first part. I want to kind of go more into the sort of more graph specific parts of the conversation, because I think there's some topics here that I wanted to expand. So the first one is, I'm not sure if you've seen this, but several times I mentioned why Jira and Elastic are a very powerful graph database. And one of the things that I actually would like to see or understand better how Neo4j handles this is the reason why Jira and Elastic, in my book, are a really great graph database is because when you look at the nodes, a node in a way should behave almost like a ticketing system, because a node, you want a description, you want a title, you want references, you want to be able to link it, you want to version control it, you want to have a discussion around it, you want to be able to easily create it, you want to have attributes, you want to have name value pairs, custom attributes, you want to have things like dates, all sorts of stuff. So if you look at it, what I'm really describing is a ticketing system. So Jira in this level is really actually quite good to capture that and allows a certain degree of customization. And he has a limitation on attributes that actually I think makes his, again, it's a one limitation, but makes it super powerful, which is the fact that you can only create name attributes, but you have a two-way relationship. So you can create queries that go up and down, sort of a certain type of a relationship. The reason I throw Elastic here is because Jira is really bad at querying and really bad at relationships. So then what the model that we created was we synchronized Jira with Elastic. So which is basically a name value pair database. And then Elastic is super powerful at indexing everything. So you basically create Jira to JSON, pump it to Elastic, and then you can run all sorts of queries based on the relationships. Any comments on this?
I mean, you're effectively building an approximation of a graph. I mean, any system that's effectively relational is a graph by nature.
Yep.
And I've seen patterns like this, and they tend to fall into what I kind of label like knowledge graph type systems. Because if you look at something like Jira, it contains a lot of different types of information depending on what it's being used for. Because Jira is a bit of a four-letter word in the industry in some shops, and people shy away from the complexity and customization of it for that very reason, and hence having to put something like Elastic on top to make it actually discoverable. It's pretty normal. And when you start thinking about looking across, whether it's Jira projects or other things, I mean, you're starting to think effectively in terms of like knowledge graph. Like, how do you ask a question of basically everything at once? Like if you have a Jira that's related to, software development, and then you've got another that's related to investigating vulnerabilities that have been reported, and then you have a customer support based one. Like, how do you connect the dots between all of these? And where I've seen Jira, no offense to Jira, but any type of system that's highly customizable, where different audiences are customizing it to their different needs, they're going to start using their own vocabularies. And that's where you end up down the semantic like rabbit hole of how do you connect the dots between the different disparate communities based off the common vocabulary. And that's a knowledge graph typically.
Yes, which is why you need a graph in order to make sense of it.
And that's why I've seen folks take things like Elastic or Solar or others and try to use things like entity extraction and text analytics and try to do some of that normalization at index time to effectively kind of build those bridges. Before I was at Neo years and years ago, I was actually at a commercial search company that we competed with Solar and Elastic, but we were fully commercial, no source available. And we had our own kind of join capability that we built and patented to do these approximations of, Cartesian joins as if there's tables inside the search engine. But we still needed to go through all these exercises of, okay, we need to create the mapping and enrichment of this terminology from this vocabulary is synonymous with this other one. And how do we form that link? Because without that, on the data consumption side, you're still left with like a very limited experience.
Yeah. But by the way, for
Graph
me,
helps us overcome that naturally.
Oh, it's the only way to do that, right? Because it's the only way to scale. So the way I look at it is that the right schema, you need to evolve into it, And in fact, I call it there's these 3 stages, and there's some people here that probably will laugh at this, but because they experienced it with me, right? There's 3 stages of I would call the graph adoption loop, right? The first one, when somebody looks at the schema, especially the ones that sometimes my teams tend to create, which is massive, right? Where we create things basically like this, right? This is everyone here is a Jira ticket, right? And then we have basically we have issue types for everything, and in fact, Abbas is here. I think he done some really cool presentations where we show this to the next level. But there's almost a 3-step approach where somebody looks at Jira and going, "Oh, this is insane. I don't get it. This is ridiculous." And then they understand the power of linkage, right? They understand that, oh, look, there's an incident. Oh, the incident points to an event. And the event points to a risk, and the risk points to vulnerability. Vulnerability points to an asset, and the asset points to the owner. Oh, that means I can find these things, right? And that actually points to the vendor, and the vendor has a link of who to contact. And then you map to the person who links to the job role. Oh, and then you actually link the vulnerability to the epic, and you link to the project that's funding that. So you end up creating the structure of the company. And when you get this right, you get this amazing database that you can get a huge amount of data out of it. And so usually the first time that happens, the people go, well, it's insane, I don't like it. Then they go, it's all a mess, right? These guys don't know what they're doing. And then they basically end up creating their own version, which is okay. So they end up basically then, so going, this, I don't understand, it's a massive mess. And then they really get into the last stage, and they really go and create their reality, and they create the mess that the next one's going to complain because they don't understand the context of that person. But the reality is, when you allow this to innovate like that, you end up having really powerful schemas, because the schema evolve as we understand better the domain.
Yeah, I mean, I can see that, and I can see the value as you build that out and continue to build it out. And if you're in a data-driven organization, it's, what's the value of that threat, or, how do you balance that threat versus the cost to upgrade versus, should I upgrade? Should I address that threat versus another threat? So, if we take this back to your threat modeling, is how can I attach value to these? So in my limited budget, what do I need to update? Do I need to patch everything? Do I need to patch critical assets? And so, these are all great ideas.
Because if you think about answering that question, it's actually very complex. Because, for example, if I give you 10 vulnerabilities, the severity of the vulnerability is just one item, is to do where it is, where it's connected to, what's the threat actor, what is the things around it. So you need that graph in order to be able to make that decision.
Exactly.
So
I agree.
So one of the things that I wish Neo4j had, and maybe you have, but I haven't seen it, I wish you had a way to edit and manipulate nodes like this. Because what you see here, although I'm using Jira, this can be done on anything, but it's fundamentally a key. You have a unique key at the top, you have a title, you have a description, you have labels, although labels are just a poor cousin of a link. I tend to say we use labels until you actually create an entity to link to, but you get descriptions, you can put attachments, you can assignments, and also the name value pairs are very important. The kind of stuff that you can create here, but the power is that you actually have a separate schema. So if you think about it, you actually have a separate schema for your nodes, and it's enforced in the schema. And then it's consistent for all the nodes. So what ends up happening is each node has a type, and the type is controlled by a schema, and the schema defines the attributes and the properties of that node. Does that make sense?
I think the other thing, Dinis, you've always said is that, at Photobox, you were using this there are lots of Jira processes running, and you're able to discover things looking at patterns coming out of the data. So that's the other piece here, which is with Neo4j, obviously it's got a huge amount of scale, but how do you get the data into it? And so I think probably the perfect marriage would be using something like Jira to capture the initial data, but making sure you can then keep it in sync in a Neo4j database.
Yeah. No, I completely agree, right? And I think that's a good example of something that, once you start to get that insight, it makes a massive difference, because then you get this sort of benefits of connecting the dots, right? To give somebody an idea.
Absolutely. I mean, if you can pump it from Jira to Elastic, you can definitely pump it into Neo4j. So, and then it just opens up your world of possibilities to look for those patterns, or, have I seen this pattern before? Or...
The thing that I've seen missing is still, folks I've worked with that have built something similar where they're modeling their current business processes or development processes in a graph, then need to layer on some sort of contextualization to the business itself, whether it's, these parts belong to this business unit or business group, who do they roll up to? It could be just as simple as who's the business stakeholder for this piece? Or I've seen people actually do quantification of creating a model of their critical business processes and like this thing impacts revenue generation versus this doesn't, to help prioritize things, because that's sort of the missing context in a lot of, even just in typical Jira usage, is like, how do you know, even just a support incident, like we always debate, is this Sev 1 or
Yeah.
Sev 2? Like, how do we, sometimes it's not very black and white. It's, you have to
Exactly.
really understand the context of, oh, this is actually impacting a system that generates a report that we need to file by a certain date, or else we get fined by
Yeah.
a government agency, that type of thing.
Exactly. Kate, can you make Abbas a co-host? Abbas, I able to find some of those things you actually presented at the summit? Because we actually had some cool examples. Also, what we've done at Glasswall about this exact topic. So hopefully you can find it. So so here's an example of that context, right? I'm not sure you can read the thing, but basically it's a project.
Sorry, Dennis.
Yeah.
What do you want me to show?
Just some of those examples of how we actually, you know, for example, dealt with incidents and connected the dots and created like basically quite intricate schemas based on the
Yeah,
data
let me
that we
check
had.
if I have anything on this machine here. Give me a minute and I'll check.
Okay, cool. So you can see like here, you basically, so this is what I was saying, like, you know, I think, do you have a way to define schemas that can then enforce to nodes in Neo4j? Because so this is you got a project who basically uses a service who actually needs a role, who's actually connected to a person. And for example, you got, again, the project who is actually part of an IT asset, who's part of a chain of the IT assets, again, mapped to roles. And then you got the vulnerability, who's mapped to the risks, who's mapped to multiple types of risks. And then you map that to a person or a role who then, and everything connects, for example, to the CEO or connects to a business entity. So you can see that with this, you know, as you navigate and you create sort of queries, which is sort of why then the way we, you know, you then query this. And of course, this was created, there was a, this workflow. See, look, you get the graph database, goes in here, Lambda functions, etc. And eventually allows you to create queries like this, where each of these is a Jira ticket, where you say this risk is connected to that one, has these facts related to these risks, with these vulnerabilities, have these actors, and then with this information, it's one of those that it looks, okay, it looks complex, but it's actually a simplification of reality. And I think, and what we didn't have, for example, is what Neo4j has, is a very good query language, or a way to do further, more complex analysis, where you then start connecting really the dots between one end to the other.
Yeah, writing SQL that would do the equivalent would be painful.
Yeah.
Even if you
exactly.
programmatically generate it, it's
Yeah.
probably going to take a lot of horsepower and time to get it to execute.
Yeah. Well, you know, I think, look, for me, like there's no debate where the only way to scale this is with graphs, right? In fact, but I think we need to find ways to scale the graph creation. We need to find a way to actually allow the graph, you know, the creation of simple evolutionary graphs that we can then basically all collaborate on.
Yeah,
Is
that's
that-
that's where I've seen
yeah.
the one approach I've seen put into practice is the idea of sort of letting those individual source systems or communities have their own schema and structure, and then having effectively a metadata layer that connects them.
Yeah.
Because it ends up being less a technical problem sometimes and more of like a political problem internally. As to
Oh,
like,
it's a massive. Oh, come on, it's a massive thing. You're mapping the organization, right? Like that.
right.
Let's be clear, right? The reason why it's complex, it's hard also, but also there's always sometimes understand that people think the organizations know how they operate. They don't.
Yeah.
I remember there was a time where our org chart was more up to date than the whole organization org chart, because we kept maintaining it, because we kept talking to people to fix stuff. And then, you know, we would go and fix the graph because, hey, we now know that this person or this team doesn't exist and is over there, right? So you know, it's an interesting thing, right? So this topic here is one of the, for me, one of the big epiphanies that that I had was when I started creating lots of graphs. And do I have here the examples? Is that when you create lots of graphs, the one of the challenges is the explosion of the query, which I'm sure you've seen, right? Where you end up having is yeah, you end up having something that looks like very quickly you have this. Actually, no, it's not this, but it'll be around. By the way, there's some really good arts you can do around graphs, right? Where is the blob? You get this, right? Or I thought I had one which was the massive, just a blob. But this is actually a nice organized one. But you get this gigantic blob of queries, because as soon as you move away from one or two relationships, everything starts to be connected to everything. And what sometimes you don't have is you don't have a way to go up. I call it go up and down the path. So, for example, like the relates to relationship is horrible, because I cannot say who relates to this relates to this, because both relate to each other. Does
Right,
that make sense?
Right. Yeah, definitely. And it's just being very specific on those relationship types.
Yeah.
Will help, but
Because
it's definitely, I mean, the whole visualization is just another whole area of expertise. Is how to make sense of this and what do you want to get back out of it.
So, for example, like so the way we do things, we say, for example, a role is managed by another role, but this role manages this. So if I wanted to find out the management structure, I just say, hey, who manages who? Or say this, start here, give me the path of managers 5 levels deep, and then you get all of that. The same thing that you have a risk, you can say a risk creates another risk, or a risk is created by, or a vulnerability is created by another vulnerability, or has a fact. So if you have these two-way dialogues, nodes, you then can create, like this is already a graph where we were mapping the tasks assigned to a person. And what's very interesting here is this was all the tasks assigned to a person, and this individual actually thought that she wasn't doing a lot because she just kept doing a lot of things. And this was a great representation of how many areas she's involved. And some individuals here actually were low performers. So it was a very interesting way to visualize the multiple types of teams that we had. And then you can create, and like here, like that's an example of this part here is already unusable because there's too many relationships. There's too many links. You almost need to decouple and find a way to connect the dots, right?
Yeah, graph visualization really starts to get into the complexity of just human interface design and building the right user interface for the right user for the right task type of thing. I've talked to folks who just think that if they just throw the graph up in a visual, that somehow insight's going to magically appear, which depending on what insight you're looking for, maybe it does, but.
So one of the things that I talk a bit later, and one of the ideas I want to just to quickly talk about is this idea of creating a static image screenshot of a graph is very important, because, and I think Neo4j, at least unless you introduce that, I used to struggle with that, because I'll get the data, I spend 5 minutes organizing the way I like it. And then what I really wanted was to be able to recreate that. What I really wanted was next time the data modifies, I want to keep that structure. So I almost wanted a way to with data or metadata, almost start telling the graph how to lay itself out without actually telling pixels, go here, go here, go here.
That's a word I wanted to say. Bloom, I think, is the answer to your request.
Which one?
Bloom is a tool, visualization tool we have that allows you to say, I want this template, I want these principles of layout and all that. Dinis, I wanted to say, you have agenda that is enough for 3 days summit. Maybe we should just let David to present an interesting use case that he brought, because we will never cover your topics. We have 15 minutes left.
No, that's a good idea.
Maybe let's just present a security use case that guys.
No, absolutely. Dave, go for it.
Let's get together for 3 days in Center Park. So I'm all for it, but we won't go through all of your points.
I agree. No, that's fine. I just want to have a whole bunch of topics to talk about. Cool, Dave, go for it. You can share.
Sure. There are a couple of things I like to share with folks. That this is from some conference material that I tend to show quite frequently. Let me see if I can go into present mode. Here we go. I think, let me know if you can't see the slides.
Yeah.
Because it's, cybersecurity space and security in general is so broad, and it's getting more and more interest, to put it simply, across the industry in the last every month that goes by. But people always want to know where to get started, because you always have this problem of like the boiling the ocean. There's a lot you can do, but where do you start? Neo4j, we offer a database platform. We're not giving you like a turnkey cybersecurity system. So there's still some work and effort that needs to go into it. And I like to highlight these particular projects because number one, they're free and open source available. And number two, they're actually very specific examples of how to use Neo4j for very specific problems. The first one, not going left to right on that list
Sorry,
for some reason.
Can you swap displays? You are presenting the technical
Yeah,
view.
let me see.
Yeah.
The
Just
classic.
swap displays, I think. Is...
How about that?
Yeah.
The classic PowerPoint issue. So from Lyft, the competitor of Uber, I can't remember when they released this, and it's constantly evolving. They created a project called Cartography. It's entirely written in Python, and it's all modular and pluggable. But the really cool thing is it's for folks who have the problem of, okay, I'd like to catalog my cloud infrastructure and services and assets, and I want to do so in the graph in Neo4j. You effectively just give this thing some access to read APIs in your cloud environments, whether it's AWS, Azure, GCP, GitHub, whatnot, and then it sucks in all that information. You can do it on a recurring basis, and it'll build a graph for you and bootstrap a Neo4j system. So this is a visual right from their GitHub page. It's all pluggable too. So if there's a system or a service that isn't supported yet, they take pull requests to add and extend features and functionality. And quite often what I find is even if you're not going to implement cartography in your environment, it actually, they've done a really good job documenting graph schema. And that's usually where people kind of get hung up, is the paralysis by over analysis of like, how do I design my graph? So I find them a really good kind of shortcut. If I can jump to my next slide, Bloodhound, and their visualization is actually going to be changing from my last conversation with them. You may or may not have heard of. They very specifically are a tool that came out of a consultancy that's focused on doing threat modeling and attack path modeling within a Windows Active Directory environment. So they've got multiple pieces to what they offer. They've got the data loading and kind of ingestion piece called SharpHound, and I believe they just released Azure Hound that works with like Azure Active Directory services. But the idea is you point this at your Active Directory farm, it will build a graph that models what's going on in your Active Directory. And then they've got some pre-canned, not only a visualization, but then some queries and ways to analyze it to find particular attack paths. They also, if you follow them on Twitter, they often tweet some interesting visuals and anecdotes about what they find during their consulting gigs. And I think the one that one of the gentlemen just shared, like within the last couple of days, was like some chain of like 6 or 7 nested groups that rolled up to domain admin. And if you actually counted up all the users that technically were domain admins through all this layers of inheritance, it was in like the tens of thousands because somebody goofed somewhere. And then the last one I like to share is more of like a kind of a tool, but it's some scripting around taking MITRE's attack framework, quickly putting it into Neo4j. And this is kind of good for not only using as like one of those metadata layers I talked about previously, but also if you're just kind of trying to design or whiteboard something, kind of to the point of getting the graph visual up, allowing people to edit things, talking about editing nodes, for instance. So this also kind of demonstrates how to take third-party structured data and put it in the graph. That's what I had prepared.
No,
I can put some links in the chat as well, because I've got all these links in the, I'll copy these out and put them in.
See, I think it would be cool to do like a couple of doing a couple of hands-on sessions, because a lot of this, the problem is, where do you start, right?
Yeah.
And how can we create some examples and some sandboxes and to get somebody to really experiment this, right? Because I agree, like a lot of these things, like if you look at AWS, one of the topics I had there was, how do you visualize an AMI? How do you visualizing what the hell, like even your open ports,
Yeah.
in AWS, I actually end up creating a graph and create a visualization. And we did more lockdowns because of that, because suddenly we could actually see across multiple accounts, multiple things. So yeah, so it'd be good if for next summer, we do a couple of sessions where it's almost like a hands-on, we create a couple of labs, or you give a couple like prerequisites, and then we try to go through some of these security tools and security visualizations, because they are amazing. They're great examples, and they allow somebody to experience graphs and start to thinking graphs.
Definitely. Yeah, I think that would be something we can also facilitate.
Yeah. So James is asking, how do we use Neo4j for alerting on change?
So if you're talking like change of somebody changed something in your infrastructure, I was just talking to somebody about this recently. I know things like, for instance, like cartography, you can run in like a Delta mode. And so it can kind of record what it saw the last run with the new run, and you could find the Delta there. That's probably, I'm pretty sure that's what I've seen done. And there was somebody else I was just talking about. Yeah, I'm working with a potential technology partner that does modeling of permissions in cloud data storage. And so like, that's one of the things they want to look for. And the way that you tend to approach that is you have to obviously store the before and after. So using the graph as basically a versioning approach. So keeping maybe a copy of a node, but then having a relationship that says, this was the previous state. You can basically build like a stateful model, so you can then walk backwards through the different versions. That's sort of how I've seen it approached.
But
go
on, James.
You can also alert if a new node joins, or somebody else, a new if you're doing network routing or something.
Yeah, at that point, it's sort of like expressing that logic in something like Cypher, really.
So
it's almost like recommendation use cases, but you're recommending somebody look at something instead of a product for someone to buy.
Yeah. So one of the comments that the guy from GraphCur mentioned, and I also experienced, is that I think sometimes debugging an Neo4j entity is pretty hard, right? And also visualizing change. I sometimes find that I think it's too powerful for its own good. I worry that every query, you're going to blow up the whole thing, because you can just make completely new set of connections. You can remove stuff. It's hard to sometimes see the side effects of the change that you're doing.
You can have a dry run for query. What it's going to do before it does it.
But what happened when we had that workflow, and it's quite funny because I saw my team doing, but I ended up doing is like you would create a couple of connections in Jira, and then you create the graph that represents that, and then you go back and you make more, and it's almost like you had to see those changes, but because you're only making a couple of changes at a time, you wouldn't be able to break it too much, but also you would actually use the broken sometimes graph to clean it up, and then eventually you had these very nice clean graphs that you created with lots and lots of interactions of making change, create the graph, making change, create the graph. So it was quite cool. Okay, another question here. Are there other important variables in charge? Ooh. I think, Fred, you might want to expand a little bit on that one. What do you mean by variables? You guys can see the question. Are there other important variables in change, or in terms of just alerting what you want to track? Maybe we can mute Fred, and then Kate, can you just allow Fred to share? Yeah.
Okay. Hopefully you can hear me.
Yeah, we can.
Yep.
There you go. You can see me now.
Hey.
I'm also another Neo4j person. So I've been thinking about this, and if you can get the graph data so that you can get feed from external sources, so like the CVE database. When you get a change in that database, you should, through the additional data, can you interrogate it so that you understand what the impact of that vulnerability is throughout the entire organizational spectrum that you're dealing with. So it's not just, you know, physical changes that you make. There are changes outside that may impact. In fact, a really good example, and it actually broke as I joined Neo4j, is the Log4j. Understanding what the impact of that quickly is absolutely critical. So, you know, how can we use this technology to really exploit the advantages that it potentially gives us? And, you know, to my question, so what are the other variables? You know, CVE to me is a typical one, but are there other databases that we should be thinking about that we can import in quickly as they change and evolve?
I think one of the, in that topic is you almost just follow the path to fix a problem, and your questions already tell you those databases. So what you talk about is saying, all right, I have Log4j. First, where is it used? So you need to now be able to consume the software bills of material. You need to be able to consume the Maven files. You need to be able to consume the reference, the SNCC, the kind of places where that will be the clue where that is used. And then, but actually, if you were being more thorough, you should then look at the source code or parts of it, which is already a graph, to say where is actually being used. It's not because you have the dependency that you actually care about, but then you're going, all right, which project is this part of? Ooh, okay, that's another graph because this is part of that, is part of this, is part of that. Is it connected to the internet or is it something internal, right? And then you go, okay, we found that out. Now, who the hell owns this? Who are the developer teams? Well, that's another graph that you need to connect to and you bring. But the thing about this is that I don't view this as complexity because this is real world. You know, people might say, oh, but that's a very complex view of on the graph. I'm like, but you're already doing this, but you're doing this in an insanely inefficient, non-repeatable, you know, non-connected way. So what I think the power here is to find those variables and then be able to, like you said, import them, but connect them and then write queries that allows, in a way, the proper use of graph technology. And one of the things that I add later, but you know, Berg, I can mention is, I also think that sometimes it's important not to have the graph as the source of the data. So I'm a big fan of using JSON YAML static places of data and then load them into a graph. But the graph is almost disposable. And what that allows you to do is allows you to DevOps your graph, allows you to very quickly be not attached to your graph because you know you can create, and it could be massive. It could be a massive graph, but you know that almost your graph is created programmatically. Because if your source of truth is your graph, then your graph becomes a pet. Then now you have to maintain it. You don't have other sources of data. And I see a lot of people doing that with Splunk. They do that with Elastic. They do that, I think, with Elastic, with Neo4j. But I think it's super powerful to look in this example that we're talking about. How do you create that graph that has a bunch of sources, but only has the elements that you need from those subgraphs?
It's a hell of a question. I don't know the answer.
Almost a session in itself.
Yes, yeah.
But,
people do think about that and are trying to figure that out because you know, we do it manually or inefficiently, and how do we prioritize and figure out the impacts? Do it in near real time.
But the other thing that, and look, we did a session on Monday, if you guys want to take a look, but I definitely feel that we should be exploring, which is there's a physical limitation of what you can do with the graph. The next evolution is a map, and Worldly maps really, if you don't know about Worldly maps, you know, is the single most important thing that I've learned in the last couple of years, probably after graphs was my big paradigm shift. But because Worldly maps allows you to put context in the graph, allows you to have direction, movement, gameplay, strategy, because ultimately that's what we want. Like on the Neo4j situation, ultimately you need to make a decision. Do I patch here? Do I patch that one? Which ones do I care? What is my attrition? What is my strategy? What are the things that I can do? And all of that is when the graph becomes a map, is when it has a lot more context, it has a lot more meaning, and it can be used a lot more strategically. So that's probably another massive topic for another session.
Probably.
Cool. All right. Any final thoughts, David, and Fred, since you and Irene? Any final thoughts from you guys?
I think we talked about a lot of things in a little bit of time, so.
Yeah.
Good, they're definitely good, and a lot of definitely use cases for graphs, and it's great to have these conversations.
So it's, Dennis, just, I looked at this when I was joining the company. I only joined 3 months ago, and I'm really trying to think, how can I use this technology as a CISO to give me insight? Because the old tools and the old methods, they are useless, and we are stuck in this group think. And maybe this will give us another view. Maybe we're looking at the wrong end of the stick.
Oh, well, you're not looking at the right end, right? Like graphs is the only way to scale.
Yeah.
Like literally, there's no way around it. For anywhere I look in security, I see a graph because and the world runs on freaking spreadsheets, which is actually a graph, but it's a very inefficient, non-maintainable, hard to link, probably already wrong after a while piece of data. But it's a graph. It's just a two-dimensional graph, right? So I know that's the way. But we need to find very good use cases. And the biggest challenge is what I found is that it takes a while to think in graphs. And I work with insanely intelligent individuals, super efficient, super clever, and it took a while to think in graphs because sometimes it's not native. I think some individuals get it more native than others, but we need to get the world to think and operate in graphs, even when they maybe don't think they are. But it works well. And we know that the biggest company in the world are graph companies. When you have a good graph, it just feels intuitive, and you don't even know they're using a graph, but you are. And I think that's what we need to do with security. And I think there's a lot of new companies. If you look at this summit, what's interesting is there's a big theme in this summit, even on automation, on writing code, extracting information from code, scaling security, which is trying to almost create graphs out of our world so we can connect them and make sense out of it.
So we probably need an interactive session where people can try out things like that.
Yeah, I think that's very important, because I think that until you experience a graph, until you really see some examples, it's hard because it's just black magic, right? It's just you can't connect it, and I think it's important that we start finding use cases that add lots of value around it. Cool. Look, thanks everybody. I can do this all day. Graphs is my favorite topic. Okay, and let's come up with a couple more sessions. And look, well, then also it's good. Like we can do a couple of pre-summit sessions. We could also do a couple of things. I feel it's definitely an area we can do a track if you want next summit. And then let's keep warming up so we can do the physical summit, right? I mean, let's do a couple more virtual ones, and then we do a full one all together.
Thanks, guys.
Thank you.
Thanks, everybody.
Thanks.